All right, hello. This is day 2 of our notes from section 5.3. Um, Today we're going to focus still on conditional probability, but I'm going to show you how to make some tree diagrams, which I think help a lot when you're doing some of these problems. It just kind of helps you organize your information and draw a picture, and it's just a little bit nicer. So, this is a scenario of if we roll a number cube. They used to call them number cubes instead of die. So if you roll a number cube twice and want to roll sixes, we're going to draw a tree diagram. So if we, let me get my pen. If we roll the dice, we could roll a 6. The probability of rolling a 6 is 1 out of 6. And the probability of rolling anything else, not a 6, would be 5/6. Okay, so that's our first roll. Now, our second roll, if we roll a 6, that chance would be a 1/6 chance. Not rolling a 6 would be a 5/6 chance. Rolling a 6 is a 1/6 chance. Not rolling a 6 is a 5/6 chance. So this was the first roll. This was the second roll. Okay, so here's some of our final outcomes. The probability of rolling 2 6s, so a 6 on the first and a 6 on the second, you just go along that tree branch and you multiply both of those values. So it would be 1/6 times 1/6, or it would be 1/36. The probability of 1 6 and 1 not a 6, so here's getting a 6 and then getting not a 6, we would multiply those two together, 1/6 times 5/6. And we would get 5/36. 1 not a 6 and 1 a 6. So not a 6 and then a 6, that would be 5/6 times 1/6. Again, 5/36. Or 2 that are not 6s. So it's a 5 out of 6 chance of not getting a 6 on the first, and then not getting a 6 again on the second would also be a 5/6. So you multiply those two together. And we would get 25 out of 36. Okay? All right, this is a really good problem. Over 10,000 athletes competed in the 2008 Olympic Games in Beijing. The Olympic Committee administered more than 5,000 drug tests to athletes. Suppose that 2% of athletes had actually taken banned drugs and that the testing procedure had a false positive, that says they took the drugs when they didn't, rate of 1%, and a false negative, says they're clean when they actually took drugs, and that rate is 0.5%. What's the probability that an athlete who tests positive actually took drugs? Okay, so let's start a tree diagram. Okay, so it says, suppose that 2% of athletes had actually taken banned drugs. So if we choose an athlete, either they took drugs or they didn't. So this is a yes, drugs, and this is a no to drugs. Okay, so 2% of the athletes had actually taken banned drugs. 2% would be 0.02. So if 2% took drugs, then what percent did not take drugs? 98%, or 0.98. Okay, then we have to read this very carefully. A false positive says they took drugs when they didn't. Okay, so they did not take drugs. Those that did not take drugs could test positive or they could test negative. So it says a false positive had a rate of 1%. Okay, so it it tests positive. It says they took the drugs when they didn't. So that would be this scenario right here, testing positive when they did not take drugs. That is a rate of 1%. So that would be a 0.01. So again, testing positive when they didn't take drugs. That has a rate of 1%. So then if that's 1%, wouldn't this be 99%? 99% of the time they test negative when they did not take drugs? That should happen, right? This is like an error in the test, the 1%. Okay, then a false negative has a rate of 0.5%. That says they're clean when they actually took drugs. So of the people that actually took drugs, they could test positive or they could test negative. A false negative says they're clean when they actually took drugs. So these people took drugs. A 0.5% is when they test negative even though they took them. So that would go right here. Now I have to convert that 0.5%, so it would be 0.005. Test negative even when they are positive. So if 0.5% test negative, then what percent would test positive? 99.5. So that would be 0.995. Okay, so 99.5% of the time, the test says positive when they were positive. Okay, so now what we're going to do is we're going to do some calculations. So we're going to multiply 0.02 times 0.995. Okay, when you multiply those, you get 0.0199. Multiply 0.02 times 0.005. When you multiply those two, you get 0.0001. Over here, multiply 0.98 times 0.01. And we get 0.0098. And down here, multiply 0.98 times 0.99. And we get 0.9702. All right, so now we can answer the question. It says, what's the probability that an athlete who tests positive actually took drugs? So an athlete who tests positive, that's the given. So that means that this is a conditional probability. What's the probability that they took drugs given that they test positive? Okay, so out of all the people who tested positive, what's the probability that they actually took drugs? Well, we can use our conditional probability formula that says that we would do the probability that they took drugs and test positive divided by testing positive. Okay, so now let's look at our number tree. The probability that they took drugs and tested positive. okay, took drugs and tested positive. That's this number right here, 0.0199. And then what's the probability that they tested positive? Well, okay, here's testing positive, and here's testing positive. So we need to add these two up because that's the total that tested positive. So it'd be 0.0199 plus 0.0098. Okay, and when you type that in your calculator, you're going to get 0.67. So that would be, let me try to type it out. Maybe that'll look a little nicer. 67% of athletes who test positive actually took drugs. Okay, so again, out of all the people that tested positive, or out of the probabilities that tested positive, these two, that's the total that tested positive, what percent actually took drugs? So this out of the total. So 67% of athletes who test positive actually took drugs. Okay. I'm going to do one more example, but I don't have enough time. This thing only allows me to record for 15 minutes. So I'm going to make a second video doing probably 3 more examples. Okay, so go to the second video now.